Hello, welcome to Z Talk. I've been working on projects related to performance tuning for Tomcat application server recently. So I think it might be a good idea to make a couple of videos to go through some common configurations or tuning for Apache Tomcat. For this first session, let's start with something simple. Let's focus on a standalone Tomcat instance to see how do we tweak the configurations to get the best performance out of it. All right. Let's talk about some basic concept first. A rookie question: what's the difference between Tomcat and Apache HTTP server? When we're talking about Apache, I guess Apache HTTP server is the first thing that could come to your mind, right? Both Tomcat and HTTP server are projects that are maintained by Apache Software Foundation. However, they are totally different things. The Apache HTTP server is primarily a file server. It handles requests over the web, over HTTP protocol. The Apache HTTP server is good at delivering images, videos, audios, text files, all kinds of static content efficiently to web-based clients. That's basically the core purpose of the Apache HTTP server. A keynote here is that it does it without any logic involved. For example, I want a text file. The HTTP server gives me the text file that I request, and that's it. Easy and simple. All right. However, on the other hand, Tomcat is a servlet engine that implements the servlets or Java server pages, or we call JSP in short, specifications. It requires a JDK in order to run, and when the request comes in, it can perform different kinds of logic. That's a huge difference. The logic could be anything. For example, authenticating a user and finding out what's the username and password in order to, access a backend resource and subsequently query a database. When you're deploying things to Tomcat, you're actually deploying web application in Java. Servlets or JSP specification allow you to do logic in the web tier. In the typical modern enterprise architecture, clients interact directly with the Apache HTTP server, and the requests that require some logic are forwarded to Apache Tomcat application server. Tomcat then interact with backend resources, for example, and send back the response. It's known as a classic three-tier architecture. I just mentioned servlet and JSP if you listen carefully. Servlet is a specialized Java class that is used in web applications, which handles HTTP requests like get, post, put, delete. The way Tomcat works is that, by the way, take a look at the diagram on the left side. It takes the HTTP request from browser and generates HTML on the fly, and then sends back the response in form of HTML to the browser. And if the requested resource is a JSP, now please move your focus to the diagram on the right side. Then the JSP is going to be translated and compiled to a servlet first before it's able to be executed by the container engine. And of course, the final result of execution is a HTML file that is sent back to the browser. I'll show you shortly in the demo session about this whole process. All right. Next, let's quickly review the three main components of Tomcat, which are Catalina, Jasper, and Coyote. Let's start with Catalina, the servlet container. Catalina is the core component that basically handles the lifecycle of all servlets. It implements specifications for servlets and JSP. Jasper is a JSP parser, or you can call it Tomcat's JSP engine. Like what we just went through in the previous slide, if a request is a JSP, it has to be parsed and compiled to a servlet before it's able to be handed over to Catalina for execution. That's basically what Jasper is all about. Jasper parses all JSP files and compiles them into Java code as servlets. And then the servlets can be handled by Catalina. All right. Also, Jasper detects whatever changes to the JSP files at runtime. So once the changes were detected, Jasper is gonna recompile the JSP files and then as servlets, and then send them to Catalina for execution. All right. Last but not least, Coyote. Coyote represents connector components, which listens for incoming requests on a specific TCP port and forwards requests to Tomcat engine. Once Tomcat receives the request, it starts processing the request and then sends back the response to the client in form of HTTP. All right, I guess it's time to move on to the main topic for this session: performance. Well, when we're dealing with complex enterprise applications, performance is always a big topic because there are so many different factors that could possibly, affect the performance of your impact the performance of your application. For example, network layer. If the application is expected to have high volume of traffic, however, the network bandwidth is not good enough to accommodate that level of volume, it becomes a bottleneck apparently. Another example, as we know, the enterprise applications usually don't work alone. Most cases, application interacts with tons of different integration points like database, LDAP authentication, Kafka message queue, external APIs, you just name it. And we know the more integration points an application interacts with, is more likely that your application performance would be affected by any of these integrations. And in this session, we're going to focus on another factor that could have huge impact on overall performance of your application, which is middleware. Tomcat is a good example of an middleware, right? Here I list out a couple of bullet points. That's going to be the main area we play with in a standalone Tomcat instance. Let's start with thread parameters. If you take a look at the diagram here on the right side of the slide, by the way, bear with my terrible drawing, but you got an idea here. The connector thread in the middle listens the incoming requests from browsers or clients, and then delegates each request to an executor in the executor pool right here. All right. An executor thread is a subprocess that is responsible for executing the actual task. By default, Tomcat creates 10 executor. Of course, it's customizable, but I guess now you could figure out the how do we increase concurrency. So how many concurrent requests a Tomcat instance is able to handle. is really depends on the number of executor threads available. So there are three key parameters that we can tweak to find the best performance of Tomcat, considering the underlying hardware. Um, One is mean spare threads, which defines the number of executor threads that will be invoked when the Tomcat server is started. And another one is max threads, is the number of additional executor threads can be created after the Tomcat server is already up and running. So basically, the number of mean spare threads means when the Tomcat server is started, there are already certain number of executor threads is ready to work immediately. Let's use like default number, which is 10 as an example. If there are 20 requests coming in, apparently only 10 requests can be handled like right away. Tomcat could start another 10 executor to handle the rest of requests if we had a max thread settings of more than 10, right? Because max thread settings means there's a certain number of threads additional threads we can create right away, right? Another parameter is called accept count. Accept count decides the size of the queue or waiting list. If the number of concurrent requests is more than the number of executor threads available, some requests have to be put in the queue until some executor is done with its current job and gets freed up, right? So after all, how do we figure out the magic number for the best performance? Firstly, we're gonna need to do some performance benchmark. We can use some performance benchmark tool to run load tests against a Tomcat instance to get an idea what is the limit based on the underlying hardware that hosts the Tomcat server. So regarding the benchmark tool, there are various options like JMeter, Siege, or Apache's Apache benchmark tool. All right, so just pick whatever you're comfortable with. So run a benchmark to get an idea, and then based on the requirement or SLA of the application, we can make a decision wisely. All right. Let's move to the second area, memory parameters. So memory parameters is another common area to play with. As we know, when an application is loaded, all the metadata. So firstly, we know heap size, right? So when we're tuning the JVM arguments, like heap size, I guess everyone knows is the first couple of parameters we tune, right? But besides of heap size, as we know, when an application is loaded, all the metadata about the Java classes are loaded in the metaspace. Metaspace was introduced since Java 8, I believe. Note that compared with heap, metaspace can consume all the memories that is available to the operating system. In other words, the amount of RAM available to the operating system is also available to the metaspace for a smooth operation of a Java application to avoid out of memory error, possibly. So that's something we should keep in mind. We should not forget about when we're allocating memory to the heap, because remember there are still something else that's gonna eat up your memory. So pay attention when you're allocating heap memory to your JVM. So I think best practices is no more than 75% um, should be allocated to the heap, right? And last but not least, HTTP response compression. I guess that's pretty obvious. The benefit we can get from a smaller response, right? Making things as small as possible is actually a key effort for improving the performance of any web applications. All right, done talking. Let's. It's time to move to the lab. So in this lab, I'm gonna show you what I talked about in the slides, and I'll show you those three areas for performance tuning on a standalone Tomcat instance. All right. So before I jump to the demo, just remember thumb up if you think it's helpful, and remember to subscribe my channel if you haven't done so, and ask questions if you have any. All right, let's do it. Installation, it's pretty easy if you're on Mac, like I do here. Just use homebrew. That's the easiest way. One command, it's gonna take care everything for you. If you're on Windows, I believe there are tons of good instruction videos on YouTube. Pick one and follow instructions, right? Here for this demo, I'm gonna use Tomcat version 9. So let me spin up the service first. All right, looks like service is up and running. Let's verify by switch to my browser and hit localhost 8080, which is the default port for Tomcat. All right, as you can see, the page is loading, and this is the default page for Tomcat. So for the hands-on purpose, I prepared a very simple demo app here. So let's do some deployment first. Let me switch back to my terminal, and as you can see here, I prepared a demo app, and as you can see, that's nothing but a indexed JXV file, and just showing some message on the page. That's it, and I've already packaged up to the demo apps.var format. By the way, here, something good to know between jar and var formats. Generally, they both are packaging formats that are widely used in Java. Jar, essentially, it's a zip file containing the compressed version of that class files and resources of compiled Java libraries and applications. Right? On the other hand, WAR stands for Web Application Archive. It's used to package web applications that we can deploy on servlet containers. A typical layout is something like this in the middle, right here. As you can see, the manifest.mf file contains useful information about these web archive. By the way, this folder, meta info, is private, so it cannot be accessed from the outside. That's why it contains another folder called web info, which is public folder, it contains all the static web resources. And we can use the same command or tools to build a var archive as we do with jar, right? So the main difference is their purpose and the way they function. Jar, as we know, allows us to package multiple files in order to use it as a library, plugin, or whatever application, right? And on the other hand, var is only used for web applications. Besides that, structure difference, as you notice, var has like a predefined structure like this, and jar is relatively more flexible from structure point of view. As you can see here, you can just put everything in the as one in the jar format. All right, so that's something good to know. Let's quickly switch back to my terminal. So what we're gonna do? So we just gonna deploy this WAR file to Tomcat, and the deploying is pretty easy. As you can see here, the left side, this is basically the structure of Tomcat. By the way, if you're install by brew, that's the location where we do our configurations, right? Use the local ops. And what we're gonna do, if you can see here, there is a WebEx folder. That's basically the location that hosts our application. We just need to copy that WAR format, the archive, to this folder. So that's basically it. So let me do that by copy document Tomcat demo app .var the archive to the folder web app. All right. So meanwhile, let me open up the tailing the log to see if the application is deployed successfully or not. Go to logs and let's monitor. All right, here, let me do that by the web app. Okay, web app folder. So I'm gonna copy these archive to web app folder. Here we go. And web apps. You can see the demo app is here. And on the other hand, checking the logs, let's tail the new Catalina log that was generated just now. And here we go. As you can see, the last message, it says the demo app.war has been uploaded to Tomcat. All right, so let's verify that by switching back to the browser again. So let's see if we can get that page as expected. So I'm gonna go to the demo app. All right, that's pretty much the page I was looking for. All right, that's for the deployment. Back to the main page, as you can see on the right side, there's a manager app button. So basically that links you to a manager console where that's basically for development purpose, where you can control the application that you deployed real quick. So, but you have to do something before you're able to get access to this management console, because like right now we haven't create any authentication just yet, so you're gonna see some error like this. It's gonna require you to put in some username and password, but we haven't configured anything yet. So then that's the 401 error you're gonna get. And here he give you some instructions. You have to create a role and username, password, something like this. So let's follow the instruction and configure the role. So back to the config folder, and here this is the file we're gonna need to modify, tomcat user.xml. Let's go to this file and create a role. All right. I just copied the whatever username and password he suggests here. Let's verify just in case you didn't see the update. So Tomcat, yeah, these two lines are basically what I just added. And then once I save it, you can see there's some updates message in the log. All right, so let's recycle Tomcat by brew services restart Tomcat 9. Alright, so I just recycled the Tomcat instance. Let's switch back to the browser and try that again. Manager. So the username is Tomcat and the password is secret. Alright, that's the manager page I was talking about. Here you can basically do some stop starts for each of your application. See here, the demo apps. That's the application we just deployed for practice, right? As you can see, there's one sessions. You can get more detailed info by going to these app, and that's the app, and you can get more like detailed information like session 90 schedule from here just for development purpose. All right, that's the manager console. Moving on, before we start tweaking Tomcat for better performance, we need some visibility first, right? I'm gonna use Visual VM as the example, but we're gonna need to configure it a little bit on both sides. So let's start with Visual VM. So I'm still gonna use Homebrew to install Visual VM. Basically, a prerequisite. Visual VM is gonna require to use Java JDK. So if you only had JRE when you start Visual VM, you probably gonna see this error here. It requests JDK. So what you need to do, you need to download a JDK and point the location of that JDK to the Visual VM property file. If you install Visual VM via Homebrew, this is the location where you need to update the JDK path right here. So let me switch to my terminal on the left side. As you can see, I've added the updated path of JDK somewhere here. All right, you're gonna do the same thing by modify this visualvm.conf file, and that's all you need to do on Visual VM side. Let's move to the right side of my terminal. On the Tomcat side, what you need to do, you need to enable JMX so that the matrix can be exposed to the outside. Like you have a server, you're gonna need some remote configurations. You can export. Tomcat can export the matrix to a remote location where Visual VM is hosted, something like that. But for my use case right here, I installed Tomcat and Visual VM on my laptop, so everything is local. So I just need to I don't need to do anything for this use case. So once you install things, you can just start up Visual VM. You should be able to see matrix. Let me hit Visual VM here. See here, the Tomcat is already reporting to my local. But if you're most of cases, if you want to monitor a remote server where Tomcat is hosted, you're gonna do that remote port, define that remote port, and authentication, something like that, on the Tomcat side. That's where you're gonna do that. If that's the case, go to Tomcat configuration and go to the bin directory and you need to modify this catalina.sh script, and by adding these additional properties here. Let me scroll up a little bit. Here, the highlight one. So basically, I just enabled the remote JMX port, define whatever ports, and then I disable the SSL and authentication like this. So you don't need to set any pass through any authentication, something like that. So once you set that up and recycle Tomcat, you should be able to configure from this remote point to basically put in the IP address and the port. Same thing, similar. The Tomcat monitor should be available, like what it shows here under local in my case. As you can see here, the JVM argument, that's what I added just now, right? And but most importantly, we can get some visibility like CPU usage, heap usage, threads, and also we can get more detail about the threads right here. All right, that's we got the visibility, so we can start some tweaking. Actually, why don't we take a few minutes to review the live threads right here to confirm what I explained earlier in the PPT slides. As you can see, firstly, live threads 31. By default, there are 31 live threads running once Tomcat is up and running. We see here in the thread section, there are 10 executor threads with Neo protocol running. That's the default executor threads we're talking about. If you remember, this is related to the min spare threads parameter I pointed out. How many concurrent requests these Tomcat is able to handle pretty much depends on these number of executor threads available for work. Now, how about playing with this config by modifying HTTP connector pool? Let me switch to my console and go to the server.xml file. Firstly, the highlights section. This is the connector we have right now. Again, the HTTP connector element represents a connector that supports the HTTP 1 protocol right here by default. It enables Catalina to function as a standalone web server in addition to its ability to execute servlets or JSP pages. This connector is listening on port 8080 when we need to customize or create other new connectors. First thing we need to figure out, I guess, is protocol. We see protocol attribute is set to HTTP 1.1 by default, but actually it can be modified to allow access to more specialized protocols. For example, you may ask if this Tomcat instance required to support HTTP 2, or from Java standpoint, we need to consider what specific protocol we should use to provide the best connection for Tomcat, like Neo or APR. I attached some articles in the description of this video to discuss the performance between these specific protocols. I guess it might be helpful when you need to determine which one you're going to use based on your scenario. What's more, we might want to use SSL handshake for security, right? So we need to enable SSL attributes. in these connector configuration, I guess that's more than likely we must configure for our real application, right? That's something in your consideration. Let's tweak this connector by creating a new executor and then compare the difference. So here in the server.xml, I just created a executor, and inside of these executor section, I just explicitly define the threads properties like mean, sparse threads, max threads. I set mean spare threads at 3 so that we can easily see the difference once I recycle the Tomcat instance. And the name prefix attributes, I'm gonna name those executors with something start with Catalina executor, right? And then after the executor definition, I'm just attached this new executor to the existing connector down here. See here, these attributes, I just point the executor. That's the executor name I just created above right here. Right? So remember this property setting, mean spare threads equals 3. Then let's save this configuration and recycle Tomcat. All right, so now the Tomcat is recycled. Let's compare the difference on Visual VM. Here we go. As you can see, remember all those 10 default executor threads using Neo protocol were gone, and those were replaced by these 3 new executor threads that we defined just now. Remember the name? The executor threads name start with Catalina executor something something. All right, that's basically it. And the number is 3, so you now understand basically these mean spare threads means that the number of executor threads that'll be ready right after the Tomcat server is started. All right, so that's basically it. Next, I want to confirm is I want to show you how does Tomcat process JSP pages, as I promised. So let me switch back to my PPT to refresh your mind. So in this slide on the right side, this graph on the right side, I explained if the request is a JSP page. Remember, if the request is a JSP page, actually, which it was in our demo just now. Remember, we just deployed an application which contains a JSP, a index.jsp. Remember, and I was requesting to access that page, right? So back to my browser, I was requesting to access this demo app. We got this JSP page, right? So let's see what happened behind the scene. Like I explained right here in the diagram. So if the request is a JSP page, firstly the JSP page is gonna be parsed by Jasper, the component, and then gonna be the JSP gonna be converted to a servlet Java file, and then the Java file can be compiled and ready to the service, ready to be executed. That's how it goes. So let's verify that by going to the Tomcat folder. So this time in the libexec, instead of the config folder, let's go to the work folder. That's basically where the actual work happens. So let's go to the work folder. Oh, so firstly, let's go to the web apps directory. That's where we drop the, so let me move up a little bit. So let's go to the web app folder. That's where I copy and drop the demo application, right? So let's go to web apps. What I can see here is once I dropped off these var archive, Tomcat automatically unzip this file. See here, there's a demo app directory, and if you look inside, is exactly the folders that inside of these archive. So Tomcat firstly automatically does that once we drop the application. And now let's move to the work directory. That's where the actual work happens, right? So move to the work directory and go to Catalina localhost, and then let's go to demo app. Org, go to Apache JSP. So here, let me move a little bit up. Right here, that's exactly what I was looking for. As I explained, that index.jsp file was first converted to servlets, right? The Java file, and then these files got compiled to be ready to be executed. That's confirms the how does it work, like I explained right here. All right. Before I kick off some benchmark testing and tweak those thread attributes, let me reconfigure the heap size because if you look at the current heap size right here, this is too big. For saving us some time for this demo, I'd like to be able to simulate some performance scenarios as soon as the load is ramping up, right? So let me reduce the memory allocation for these GVM. By the way, here comes some best practices when we need to make some changes in Tomcat. Remember, back to my terminal. Remember, I added some arguments in these Catalina shell scripts to enable remote JMX, right? Actually, following the best practices in your real environment, instead of adding or tweaking configuration directly in these original Catalina shell scripts, it's better create a script called setenv and put all your changes there. Because if you take a look at the Catalina shell script and search for setenv, you can see there is already a condition or logic in place here, highlight right here. So when you start your Tomcat process, it's actually looking for these setenv.sh file under bin directory. So if there is by default there is no setenv script. It doesn't exist. You have to create this file. So when you create this file and you start Catalina, so you're gonna searching for these setenv scripts. If it's there, you're gonna associate whatever changes in this file along with the whatever configuration in the original Catalina shell script. That's a better practice for configuration. All right, cool. So let's take a look at the setenv. I already created this file and add the configuration or arguments that we need to change here, like heap allocation, and I also moved the GMX configuration from the Catalina's shell script to these setenv scripts. All right, so let's recycle Tomcat and see how it goes. While we're waiting for the recycle of the this Tomcat instance, another use case from automation point of view within these setenv scripts when we're managing our real application or infrastructure I can think of we need this process of allocating memory to Tomcat dynamically, or to be more intelligent based on the underlying hardware instead of just hard-coding in a specific value. So what we can do, we can add additional logic to these scripts. For example, we like the script to check the total memory size of the server first. And on the other hand, we can define a JVM heap size percentage variable in our configuration management tool like Ansible, and we create an Ansible role and pass that variable into the script such that this script is gonna calculate the value for us based on the type of server we choose to avoid any configuration error. Right? Imagine we had a T2 micro E3 instance for our Tomcat on our dev environment, which is 1 GB, right? And we allocate 50%, like 512 megabytes to the heap. And when we move to our production, like we're gonna have like a M5 large, for example, which is 8 GB. If we were hard coding that value, that 512 megabytes, to the argument, JVM argument, and forgot to update that when we move to production, that's going to be a problem, right? And this kind of human error would never happen if we put that kind of logic or that kind of automation in place to the scripts. So, for example, we can do something like we use the script to script understand the memory size and script this value out of these commands, and then do that calculation by like time the percentage we define in or Ansible, something like that. Then we would never have this kind of configuration error potentially. All right. Tomcat is up and running now. I further tuned the heap allocation to this JVM down to 128 megabytes right here. See? And on the threads configuration, please move your attention to the left side, the highlight section of the executor threads. I set the mean spare threads as 1, max threads as 2, and I also added another 2 attributes, which were max connection 20, accept count 10. So hopefully I can simulate some performance issue while the load is kicked off. All right. So now let me step back a minute and restate what these 4 thread attributes are all about to refresh your mind, because I believe these 4 attributes are the most important ones that we need to tweak for almost all of our cases. So we've seen mean spare threads and max threads just now. So to validate one more time, we're supposed to see only one live executor thread right now. So let's jump to the threads detail right here. Here we go. There's only one executor thread running right now. Looks good. And now let's move to accept count. So the accept count attribute is the max queue for incoming connection requests when all possible executor threads are in use. And any requests received when this queue is full will be rejected. The default value for accept count is 100, and a correlated attribute is max connections. These 2 attributes usually work together. Here the note is that when max connections has been reached, the server might continue accepting requests, which depend on the accept count threshold, of course. However, it won't process it. These additional connection requests would be blocked until the number of connection being process falls below this max connection threshold, at which point the server will start processing new connections again. All right. So I guess it might be it still might be hard to understand and remember those concepts if I just so that it is fast understood. So for better understanding, we can compare these concepts with a movie theater scenario. So let me move to my PPT. Here I draw a picture of a movie theater. So to watch a movie, the process is simple. People first get into the lobby to buy a ticket, wait to get into the theater to watch the movie, and then enter to this theater to watch a movie. Right? So follow the flow of this picture from the beginning right here. So people are trying to enter the lobby to buy a ticket first. So once they're inside the lobby right here, people are forming a line to buy tickets. At this very moment, they are not assigned to a theater to watch movie just yet. That's exactly max connection concept is all about. Normally, the size of a lobby is bigger than theater. However, even lobby has a capacity. To maintain a happy experience, we don't want too many people flooding into the lobby, right? So we got a security guy standing in front of the entrance of the lobby right here. So the security guy's job is to count the coming customers. Once that number is reached to the accept count, well, those new customers right here will be blocked, will not be allowed to get into the lobby at that time, because we know all theaters and even lobby are under full capacity at that point of time. Okay, and well, a while later, the movies are done. Right, the movies here are done. So people in the theater right now watching movie are heading out. Now the next group of people waiting in the line, these people are ready to get into the theaters to watch their movie. And accordingly, at that time, the lobby had got some room to accommodate new customers outside here to get in the lobby to buy tickets. So that's basically the flow. So hopefully these comparison helps you understand what's accept counts and max connections all about. Alright, I'm ready to generate some load to see the performance. I'm going to use Apache's benchmark tool to generate concurrent users accessing the demo app endpoint that we just deployed, that simple page. With different level of concurrency, we're going to see the performance difference, between different sets of configurations. Here on the left side, the highlight part, this is the command or the Apache benchmark CLI. So the test cases, I'm gonna generate 10,000 requests in total. The request is hitting these demo app endpoints, and I'm gonna run a couple of rounds of same tests with different concurrent users. So if I start with 40 concurrent users, I'm gonna got something like this. So this is the stats of response time. So I want to note down these response time at different percentage of requests. So let's compare. So to save us some time, I've done the test at half the time. So let me just show you the results with different sets of configuration. The first, let me expand it a bit. So here, the first sets of configuration. I'm used like one minimum spare threads and two max threads, and max connection is like 10, and accept counts like 5. And with concurrent users ramping up from 20, 40, 50 to 60 respectively, using these two sets of configuration. By the way, I did not add the factor of JVM settings in the equation just yet. So we already see a good pattern with different, with more executors, we got better performance. This is just two executors working together. We can see a pattern. The response time is ramping up at 60 concurrent user level. We already see the bad response right here. See, it's almost 19 seconds, right? On the other hand, if we increase the threads, executor threads, we see definitely better results. See, at the 60 concurrency level, the result is much better. See, the worst one is only 6 seconds. It's bad, but it's way better than this guy, right? So this is just give you an idea. With this kind of good understanding, based on the performance stats, we can make more accurate decision like what type of server we should use if we have this number of users visiting our site. Or we can also tell if like are we currently wasting our system resources with this current level of user loads, with this infrastructure, something like that. Yeah. All right. The last tuning I'd like to share, HTTP response compression. As I said, a common sense, the smaller it is, the faster it is transfer over the network, right? So to improve the performance of front end, making request and response as small as possible is a big effort. When we're talking about reducing the size of a file, I guess the first thing comes to mind is to compress the file before sending it out, right? So to enable compression, what we can do is, firstly, let me show you an example. Here is the homepage of my Tomcat, right? Let me open up the developer console and go to network tab and reload this page and localhost. Let's see how big of the files were transferred. Here we go, 11.4 kilobytes transferred. So let's see what we can do to make it better. Let me switch back to my terminal, and in the server.xml file, let's locate the connector section. Here we go. So to enable compression, we need to add a couple of more attributes, something like this. So first thing, we need to make compression on, right? And then every operation, additional operation has a cost. So compression gonna cause some overhead. We want the compression to make files smaller, but we don't want to have too much overhead. So that's why I set these compression mean size. So for those files we're trying to compress, if those files are already small enough, we don't have to compress them before sending them out, right? And the last one, compression min type. So we want to compress certain type of files, not everything, like to avoid breaking or application. So for example, I just want to compress HTML files, XML files, those kind of files, right? That's why where you define the targets. So what type of files you want to compress, right? So after that, save it and recycle Tomcat. Okay, recycle is done. So let's take a look how much size we reduced after enable compression. So remember this number, 11.4 kilobytes. Let me refresh. All right, this time only 2.3 kilobytes were transferred. That's pretty much what we want to see. All right, that's all I want to share for this session. Hopefully, it helps you one way or another. Again, thanks for watching and leave comments if you have any question. All right, see you next time.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.